In the last of the mini-series, we'll be talking about how we can balance a redox equation in a basic environment. This as well is also for the honors chemistry class. In our basic solution, as the question states, we have silver metal and zinc ions making silver 1 oxide and zinc metal. So the very first thing we have to do is again separate them into half reactions as we see here. We're seeing our silver metal becoming a new compound, and we're seeing our ions of zinc forming a neutral zinc. The second thing we have to do is again balance all of the elements except for our hydrogens or oxygens. So when you look across the first row for our silvers, you notice you have 1 silver on the left but 2 on the right. You need to balance it on the left with 2. You notice for zincs, they are equal, a 1-to-1 ratio. In the third step, you have to add water to balance out all the oxygens. So if you look on the very first row, you originally only had 1 oxygen on the right-hand side, so that's why we put in the water on the left-hand side in the reactants next to the silver. In the bottom reaction, you don't have any oxygens. Step 4, we now have to add protons to balance out the hydrogens that were found in water. In our top reaction, you have 1 water, so therefore you need 2 protons. In our bottom reaction, you don't have any hydrogens, so you don't add anything. The fifth step is to then balance the charges of the elements that were undergoing the redox. In our first reaction, we are looking at silver, that is neutral, going into a silver ion. We determined that you are going from a neutral 0 charge to a positive 1 charge in the compound. That means silver is losing 1 electron. In the bottom reaction, zinc ions are turning themselves into neutral zinc, which means you're going from a +2 to 0, which means zinc is gaining 2 electrons. So it's determined that if you have 2 moles of silver and you're turning them into 2 silver ions, that means you have to have a positive 2 electrons. You have to lose 2 electrons. For the zinc on the bottom, to go from zinc +2 to neutral zinc, you also have 2 electrons that are being added as a reactant. Note the differences between reactants and products. The sixth step is now to take the least common multiple between the electrons to make the electrons the same. Fortunately, in this situation, there is no change. Right now, our electrons are the same and we can proceed to the next step. However, if this was a different formula, now you would have to find the LCM. You would have to multiply the top or bottom reaction by a number that would make the electrons equal to the least common multiple. The seventh step is to add the reactants and cancel out all the electrons. So again, if you write your 2 different half reactions right on top of each other with the yield arrow in the middle, you can put this line to represent the difference between your reactants and products. The next thing we're going to do is cancel out all of the electrons, and we are going to add all the reactants together and say the yield to make all of the products. The 8th step is to add hydroxides to balance out all the H+ ions, and then combine them to make water. In the reactants, we're noticing we have H2, so that means we need to add 2 hydroxides to the H+ ions from water. Of our products, we have 2 H+ ions out there, so we have to add 2 more moles of hydroxide. When we add those 2 moles of hydroxide to the H+ ions found in the products, they instantly turn into water. So you should have 2 moles of water. That's what it simplifies into. Finally, the very last thing you have to do is cancel out all the terms that are common, anything that's similar on both sides. So you only see that you have waters that are similar on both sides. The water that is a reactant is going to be canceled out, therefore we'll have water as a product. So your final formula should be neutral silver plus zinc ions plus hydroxide ions. We'll be creating solid zinc, silver oxides, and water.